Manufacturers today are under relentless pressure to increase throughput and cut scrap. Yet even the most advanced lines struggle with one critical challenge: balance. A production line, whether in bottling, packaging, electronics, or consumer goods, is a delicate ecosystem. Each machine must operate in harmony, but real production environments bring microstoppages, disruptions, and fluctuating buffer levels. When just one piece of the equipment slows down, the whole line can fall out of sync, reducing throughput and increasing downtime. I'm Riley, and we're here at MXD today to showcase how IndX and Aleph harness the intersection of edge computing, plant simulation, and machine learning to create a competitive advantage. To design, build, and optimize a high-performing production line, we use AI-ready simulations and real-time shop floor data, validating the best configuration and cycle times to meet throughput efficiency targets. But running an optimal line is only the beginning. Once production starts, real-world microstoppages, operator delays, and material inconsistencies push the line away from its design performance. Keeping the equipment synchronized becomes a continuous challenge. For example, running a machine with a high throughput that faces a stoppage can quickly cause an overflow in the buffers behind it, leading to scrap and further delays. The same simulation model that designed the line becomes the virtual training environment for the AI speed management controller. Using real production data captured by industrial edge devices, the AI learns how the line behaves under disruption. In this safe virtual environment, the AI SMC experiments, learns, adapts, and discovers the best strategies to keep the line balanced automatically. Once trained, the SMC model is deployed directly on Siemens edge devices. Here, it reads live production data and writes control values in real time. The model continuously analyzes buffer levels, machine behavior, and throughput, adjusting equipment speeds to maintain optimal flow and minimize microstoppages. By combining simulation, industrial edge data, and AI-driven optimization, manufacturers achieve higher throughput with existing equipment, fewer microstoppages, stable flow and optimized buffer usage, low energy consumption through smoother operation, reduced operator intervention, reduced scrap, and a line that automatically adapts to variability. This is the future of modern manufacturing. Intelligent, self-optimizing, and powered by AI, simulation, and edge computing.